Okay, so hi everyone. So I'm going to talk about how to create a responsible and responsive research program for AI. That's too large of a promise. I'll go in that direction though. The main thing that I really want to do is I want to lay out how I think about AI and what the ethical risks of AI are and why we are paying attention to AI risks, ethical risks in particular. So when I talk about AI ethics, there's a primary distinction that I like to start off with because talk about AI ethics is often it's a bit of a mess. So I like to start off by distinguishing between what I call AI for good and AI for not bad. A lot of times AI ethics and AI for good are sort of rammed together as one thing, but I don't think that's the case. AI for good are people who want to ask or who are pursuing AI for good are asking the question, how do we pursue our ethical goals, or in the case of a business context, our business goals? How do we pursue ethical goals using the powerful tool that is AI? That's AI for good. So we've got some goals that wear their ethical credentials on its sleeve. You might think about the UN Sustainability Development Goals. How do we, decrease poverty, increase education, yada, yada, yada. And how do we do that with the powerful tool that is AI? That's AI for good. AI for not bad is, how do we pursue our normal goals, ethical, at least ethically neutral, if not ethically good? How do we do it in a way that's not ethically problematic? So we're not trying on the face of it to pursue ethical goals. We're just trying to do, if you like, business as usual. How do we do that without messing up, ethically speaking? That's AI for not bad. And that's my focus. I focus not on how do we achieve great things, but how do we just stop the nightmares? That's the primary focus. So I talk about AI for not bad. You can call it AI ethical risk mitigation if you like. That's fine too. And then once we're focused on AI for not bad, I like to distinguish between what I call content and structure. So on the content side of the house, it's what are the sources of ethical risks? And as for structure, it's how do we avoid that? And the reason I think this distinction is important is that most people, they hear the ethical risks of AI, they're sort of vaguely familiar with it. Oh, something about black boxes and something about bias discrimination. Okay, what do we do about it? And I think that is way too fast. You don't know what the actual sources of the risks are, so you can't adequately identify and manage those risks. So I think what we see a lot of is people getting a very thin sense of what the risks are and then rushing to the let's rush into action. Let's find out the answer. What do we do? Let's be pragmatic about this. And I think that's a bit silly because this is no different than any other case. If you don't really understand the source of the problem, your solution is not going to be adequate. And I think we need to spend more time digging into what are the sources of the risks. I was going to say next slide, and then I realized I'm clicking this. Okay. So let's start with the content side of the house, because I think if we go deeper on that, we're going to be better at the structure side of the house. I'm not going to get into too much detail here because I've got something like 15 minutes, but we'll do what we can. So when I think about actually, let me back up a second. I want to say one thing about how I think about what AI is. Kevin, I want to, at some point, I want to argue about your definition. Mine is extremely simple. It's just software that learns by example. That's it. It's software that learns by example. End of story. Thank you and good night. If you want your AI, first of all, we all know what software is, right? We all use it all the time. That's easy. We know what it is to learn by example. I showed my kids a bunch of pictures of pigs. Now he can identify pigs in pictures. He's amazing. I don't want to brag, but he's kind of gifted in that arena. For more high fluent examples, if you want to learn what Impressionist paintings looks like, I can give you a couple examples of Impressionist paintings and you'll get a good sense of what they look like. So when you go into a museum, you'll say, oh, that's an Impressionist painting and that one is not. So we know what software is, we know what learning by example is, and AI is just software that learns by example. If you want to understand, you want it to sort of be able to read resumes and say this is a good resume or this is a bad resume, give it a bunch of examples of resumes that some human at some point or other said, yeah, this person deserves an interview. And the ones that they said, this person doesn't deserve an interview. Give it all those resumes. It's going to learn. There's caveats, but everything else equal, it's going to learn how to spot good resumes and bad resumes. You want it to learn from medical profiles. Who's going to develop diabetes in the next 2 years? Probably. Well, give it a bunch of examples of medical profiles of people who develop diabetes in the next 2 years. And it's going to learn more or less how to spot in the new cases that you give it, whether the person's going to develop diabetes in the next 2 years. If you want it to learn how to put words together in a coherent fashion, give it a bunch of examples of words being cobbled together in a coherent fashion. Let's say magazines, books, the internet, and it's going to learn how to shove words together in a coherent fashion. So I don't care if you're talking about AI that's about task specific, approve, deny the mortgage, tell me the probability of developing diabetes. I don't care if you're talking about generative AI. We're just talking about software that learns by example. And if you'd like to sound fancy, then you can use the word data. That is just a fancy word for example. So if you want to sound fancy, you can say AI is software that learns by data. If you want to sound even a little bit fancier, you can say it learns by using training data. It's just all software that learns by example, though. And I actually think that it's important that I don't know if dumb down is the right expression, but make it as simple as possible, because data scientists will push people around who are not technologists with big fancy words, training data, deep neural nets, and then the non-technologists, the non-data scientists say, deep neural networks, I don't really understand that. What the heck is a transformer? And then they're out of the conversation. But you can't be out of the conversation. If the non-technologists are out of the conversation, we're in really deep trouble. So if we don't talk about it like kindergartners, software that learns by example, then we're not going to do well in pushing back against the technologists. So that's why I just talk about software that learns by example. And if you want bad AI, defective AI, give it bad examples, not enough examples. If you want good AI, all else equal, give it good examples. And I can put that in a fancy way. I can say things like, if the training data of your AI is not sufficiently representative of the vast array of contexts in which you're going to deploy your AI, then you'll have too many true positives or false positives, false negatives, such that it's no longer functional in the intended use case. Blah. You just didn't give it, you gave it bad examples, all else equal, and now you've got defective AI. Don't let people push you around with fancy words. Okay. Now, diatribe over. Back to this. Once you get that software, that AI is software that learns by example, you start to see particular ethical risks becoming not merely possible, but probable. Ethical risks being possible is no big deal. Possibility is cheap. It's possible that 5 minutes from now, a bird's going to fly through that window, but there's no evidence, that door, but there's no evidence that that's going to happen. So yes, risks are possible. That's easy. What's sort of interesting about AI and ethical risks is that there is a certain subset of ethical risks that are probable by virtue of how AI, or if you like fancy, somewhat machine learning works. So for instance, all those examples, they're often about people, or it's data about people. And so what's the fuel of AI? Often data examples about people. What does that mean? Well, if an organization wants to have really good software that learns by example, then it's going to want to get as many examples as possible. It's highly incentivized to get as many examples as possible, which means it's highly incentivized to get examples, the acquisition of which may constitute a violation of privacy. Examples, data is the fuel of machine learning. You want to go far, get lots of fuel, so you're incentivized to get the kind of thing that could constitute a violation of privacy. That's probable, not possible. It's probable, given how AI works. There's other ways that privacy can get violated, which we can talk about, but I'll save that for later if people are interested. How does it learn by example? So let's take a really simple case. You give it a picture of your dog Pepe, or give it a bunch of examples of your dog Pepe. Pepe, jumping in the dark, jumping when it's light outside, eyes closed, eyes open, yada, 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 yada. Now, when you and I see pictures of Pepe, we are looking at a nose, 2 eyes, ears, and the like. When the software that learns by example is looking at all those pictures, it's looking at the phenomenally complicated mathematical relations among the thousands of pixels. Let's just call it a 55-page mathematical formula. It's too big for us to keep in our heads. We just can't do it. We're too finite. We're too dumb. Which means that when the AI says, yeah, 5 minutes, I'll talk faster. When the AI says, yeah, that's Pepe, or no, it's not Pepe, it's doing so on the basis of a mathematical proposition that we can't keep in our heads. So that's how you get the black box problem. We don't know why it's coming out with these outputs. And then finally, the bias issue. There's lots of ways this comes about. Perhaps one of the most famous examples of this is facial recognition software. At least early on, facial recognition software was really bad at recognizing black women. Why is that? Well, we gave it lots of pictures of white men in various lighting conditions in different contexts and different poses. We gave it relatively few pictures of black women in various lighting contexts and various positions. And so, lo and behold, since it didn't have enough examples to learn from, it was bad at recognizing black women in photos. There's loads of examples of this. I can do gender. I can do race. There's all sorts of ways this happens and goes sideways. Notice that for each one of these things, It's just because of how machine learning works. It's how AI works. It's learning by example. And so if you give it examples, it's learning very complex mathematical patterns. It's of the nature of the beast that it's not going to be able to, we're not going to be able to explain its outputs. And it's going to wind up with outputs that reflect various kinds of ways in which you didn't do a good job putting together the examples, putting together the training data. Probable, not merely possible. Okay. When you get to generative AI, large language models in particular, other kinds of things are quite likely. I'm just going to talk about hallucinations. Kevin touched on this point as well. Hallucinations, it's kind of an odd word for saying large language models like a ChatGPT put out false information. Why is that the case? Kevin can give you a much more technical explanation. Here's my explanation. It's software that learns by example. What did it learn to do? It learns to cobble words together in a coherent fashion. Coherence has nothing to do with tracking the truth. And so it puts together words that's in a way that's coherent, but not in a way that's actually tracking the way that the world is. So that's why it's of the nature of the beast to give rise to hallucinations, false outputs, whatever you want to call it. Okay. So now we're going to begin to build out this diagram a little bit more. All of those things are not merely possible ethical risks, but they're probable given how AI works. One thing that I didn't mention yet is that then there's all the use case specific ethical risks. So there's some ethical risks that are certainly are likely or probable not because of the nature of the beast, but rather because of the purposes to which you put the beast. So if you decide to use AI for self-driving cars, now you've got killing and maiming pedestrians as a new ethical risk. That's not because of the way AI works. It's just because you decided to do it for that kind of high risk scenario. Okay. In all of this, before I get to that, one thing that you don't want technologists to tell you is that they got it. They don't got it. They think they do. Often bias, you will talk to most data scientists, they think they figured out bias already. No, we figured it out. We've got these quantitative metrics, quantitative analyses and methods for decreasing bias, and we've got it all figured out. It's not the case. It's not true. There's loads of qualitative, substantive, ethical questions that are on the table that your data scientists are not well equipped to answer. Not as such, but just given their training. There are plenty of data scientists who are smart, ethically minded, can do good qualitative assessments, but as a profession as a whole, not so great. I'm a philosopher by training. I can talk a little data science-y, but you wouldn't want me to be an engineer. So here I just want to highlight some of those qualitative ethical questions that are on the table. What's the appropriate metric for bias? That's upper left-hand corner. So let me give you a very quick insight, I hope, into why quantitative is not sufficient. So let's take an example in which you're distributing some good or services across a large population. You might say, well, do we distribute this fairly across relevant subpopulations? White, black, Asian, white women, Asian women, black men, blah, blah, blah. Did we do it fairly? The data scientist is going to say, well, we can measure that. We've got these 24+ metrics for measuring whether or not it's been distributed in a fair way. And then the question is, well, which metric? Because here's the thing. Those metrics for measuring whether it's been distributed fairly are mutually incompatible. So if you score well on one, then necessarily you're going to score poorly on the other and vice versa. And so now you've got this substantive, ethical question. What's the appropriate metric for bias in this particular use case? And when I say appropriate here, among other things, I mean what's ethically appropriate, also legally, etc. Who should have control of the data? Is our chatbot objectionably manipulative? Maybe it's trying to get informed consent a little bit too hard. What's the appropriate benchmark for safe deployment? That's not a math question. None of these are math questions. Should we defer to the AI's quote-unquote judgment? Does this place an undue burden on the user or on employees? Is this our responsibility or the user's responsibility? Is it the government's responsibility? We've given an explanation for how the AI works, but is the explanation good enough? Is it suitable for the purposes for which the person needs the explanation? And should we defer to our clients or that culture's ethical standards, or should we manifest our own in the development and design and deployment and monitoring of our AI? All of this is just a small glimpse into the set of qualitative questions that arise. So why do we need to understand how AI works and AI ethics in the context of, for instance, research on human subjects? There's always going to be these qualitative questions. They're never going to go away. And we have to make sure that the right kinds of people are involved in answering those questions. And we can't simply defer to the data scientists. Thanks so much.